This session will introduce you how to use ASPEN Plus to design more sustainable chemical processes in terms of environmental and economics. Designing more sustainable products, processes, or technologies usually involves the evaluation of environmental, economics, and social aspects. These are what we call the three main pillars of sustainability, which are informally referred to as profits, planet, and people. In terms of process engineering, design engineers often involve mainly economics and environmental aspects. The flowsheet simulations we have developed so far are usually what we call base cases, which typically considers only technical performance and more often not optimized in terms of energy consumption and economic aspects. To improve or modify the base cases to become more sustainable, we need to perform energy and economic analysis of the processes. In order to perform those tasks, you can use ASPEN products included in the ASPEN 1 engineering sheet. First, you need to create the process flowsheet simulation in the process simulators, such as ASPEN Plus or ASPEN HYSYS. With the integrated user interface between the software, you can perform the economic and energy analysis within the ASPEN process simulators. The process simulators will interact with the ASPEN process economic analyzers or APEA and the ASPEN energy analyzers running in the background. To perform the results and risk analysis of the heat exchangers, you can use the ASPEN Exchanger Design and Rating or ASPEN EDR to assist in this task. In ASPEN Plus, there will be the activated dashboard appear above the main workspace in this simulation environment. The green panel is the economic analysis performed by APEA. To do the economic analysis, the APEA will map the equipment models, size equipment, estimate cost of the plant, and conduct the investment analysis. The blue panel is the energy analysis performed by ASPEN Energy Analyzer. This will perform the optimization of energy consumption by using pinch technology, calculate the potential savings and utility usage, and carbon emissions from both processes and utilities. The brown panel is the ASPEN EDR, where you can perform the detailed modeling of heat exchangers and calculate the operational risk for a rigorous exchanger model. If the dashboard does not appear, click Activation Dashboard in the View tab of the ribbon. In this session, I will introduce you about how to perform the energy and economic analysis within the ASPEN Plus process simulators. So, let's get started with the energy analysis. The efficient use of the energy is one of the basic assumptions of good process economy. Energy consumption is a significant cost in many processes. This cost can be reduced by minimizing energy loss, recovering waste heat from hot streams, and by combustion of waste streams with energy potential. Heating and cooling can be accomplished by heat recovery between process streams. However, an economic analysis of heat recovery needs to be investigated because Heat recovery requires some capital and operational costs, and sometimes the investment cost might not be economically feasible. In the process with a large number of hot and cold streams, the design of heat exchanger network, or HEN, for optimal heat recovery represents a complex task. Therefore, the process energy integration is one of the most often reasons for using process simulation. ASPEN energy analysis can be used to explore energy saving changes in our plant model to reduce energy costs. The steps for energy analysis are usually as follows. Step 1 is to analyze the amount of heat available for recovery and potential of the process for using such heat. Step 2 are to size the equipment and perform the economic analysis of heat recovery system. To optimize the energy consumption of a process in ASPEN Plus through the use of ASPEN Energy Analyzer, you need to do the following. First, you need to create a process simulation. For best results, use utilities features to represent our utility fluids. After that, click Run the simulation and make sure that the simulation is converged without error. The status could be shown as Resource available or Resource available with warnings. Then, click the Activated Energy panel and the configuration sheet will appear. Use this sheet to configure Activated Energy Analysis. Then, click the Off switch to turn on the Activated Energy Analysis, as shown here. The model is then sent to ASPEN Energy Analyzer to perform the energy analysis. The results are displayed in the panel, as shown here. The potential utility savings found are shown in two different forms. The first one is shown in the global enthalpy flow units, such as 12.19 megawatts. And the second one is shown as the percentage of the actual current utility usage. These are the maximum possible savings opportunities as dictated by the thermodynamics. Please note that they don't refer to any specific set of design changes. After the calculations are complete, the energy analysis form will appear. There are several tabs in this form to see more details of the analysis results, as shown in the next page. You can click Define Design Changes on the Design Changes sheet to view the design changes found by the Activated Energy Analysis. This table shows the sheet that report the calculated results of the energy analysis. The first sheet is Savings Summary, where you can view the total utilities and carbon emissions results. The Utilities sheet provides a summary of the usage of each utility. The Carbon emissions sheet provides a summary of the carbon emissions from each utility. Exchanges sheet provides the information about all exchanges considered by Activated Energy Analysis. The Design Changes sheet provides the details on design changes considered by the Activated Energy Analysis. And the Configuration sheet, where you can specify options for the Activated Energy Analysis. You can use the energy analysis environment to explore the combinations of the process changes suggested by activated energy analysis. There are some cautions about the using of energy analysis related files. The energy analysis creates two additional files in the same folder as the ASPEN Plus file, and they are saved when you save the simulation. The two additional files are an .xml file and the .hch file, both with the same file names as the simulation. When you reload the simulation, ASPEN Plus looks for these files. So you need to make sure that both files are in the same folder of the original ASPEN Plus file to be able to use the energy analysis environment as well as the ASPEN Energy Analyzer. If both files are missing, then the energy analysis environment will be empty, just as if you never ran the energy analysis. Don't modify the .hch files outside the ASPEN Plus simulation. Doing so could break the synchronization between ASPEN Plus and the ASPEN Energy Analyzer. If you want to work with this file in ASPEN Energy Analyzer, make a copy first and work with the copy version. Here, we come to the topic of process economic evaluation. Cost estimation of different alternatives enables optimization of the process design. The objective function in optimization is usually the maximum profit or minimum cost. The integration of the economic analysis into conceptual design enables assessing the design's profitability and eliminating unfeasible routes in early stages. The two major types of cost involved in the project are capital cost and operating costs. Usually, the estimation of the capital cost is based on the purchased equipment cost. ASPEN Process Economic Analyzer, or APEA, is a sophisticated software interface within ASPEN Plus and engineering database systems used by these simulators. APEA simulator capabilities such as equipment sizing, information database, and process conditions enable rapid and accurate estimation of the project cost. There are some essential terms regarding the cost analysis in process design that you should be aware of. The capital costs are costs associated with the construction of a new plant or the modification of an existing plant. They usually involve fixed capital, which are costs to supply the required manufacturing and plant facilities, and the working capital, which are the costs that are necessary for plant operation. The fixed capital costs consist of the following items: the direct costs, which are the costs relating to the purchased equipment, installation, piping, instrumentation, and controls, for example. The indirect costs, which are the costs relating to the engineering and supervision, legal expenses, construction expenses, for example. The next one is the operating costs, which are costs connected with the manufacturing itself and general expenses necessary for production, product development, and its distribution. There are two major types of operating costs. The manufacturing costs are the costs involved raw materials, utilities, operating labor, maintenance and repairs, etc., etc. And the general expenses, which usually involve the administration, distribution and marketing, as well as the research and development costs. There are several useful terms regarding the profitability analysis of a process design. The first one is gross profit, which is the amount of profit calculated by subtracting cash expenses from the revenue. The revenue essentially means the total income. Cash expenses is defined as all expenses minus depreciation. Net profit before tax is the revenue minus all expenses. The net profit after tax is the multiplication between the term of revenue minus all expenses and 1 minus tax rate. The rate of return on investment or ROI. This term is defined as the annual net profit divided by the invested capital multiplied by 100. And the last one is the payback period or PB. This term is the total investment divided by the average annual cash flow. The ROI and PB can be considered as the economic performance indicator, which will be calculated as the result of the ASPEN process economic analyzer, which will help the process designer to decide which process alternatives are better for investment. After understanding the essential terms of economic evaluation of the process design, let's see how we can use the activated economic analysis in ASPEN+. Before you can run the integrated costing, you should configure the model with costing information. To do so, go to the Economics ribbon tab. In the Prepare command group, use Costing Options form to specify the costing template, scenario name and description, and optionally the operating life of the plant, length of plant startup, and the date for the start of basics engineering. The costing template determines the units of measurement and currency used by APEA, as well as the schedules used for calculating costs and other options. This may differ from units and currencies used in ASPEN+. Pre-configured templates are available for several locations around the world, with appropriate currency and cost schedules, each in inch, pound, or IP, or the metric units. You can build your own template in standalone APEA to specify these and other options. The scenario name is used to identify this costing scenario. APEA files are stored in a subfolder with this name. The description appears in APEA reports. The operating life of the plant, the length of plant startup, and the start of basics engineering affect APEA's cost calculations. If these information are not specified, the default values from the costing template are used. In order to get raw material results, specify stream prices by using the streams price form. For best results, configure your model to use utilities. If you do not, the APEA will gauge the utility needed but configuring the model to use utilities actually available in your plant and specify the cost of those utilities will produce more accurate results. After completing configuring costing, click Run the simulation. You must start with a converged simulation to perform costing. Then, in the Activated Economics panel, click Off button, as shown here, to turn on the Activated Economic Analysis. By turning on the Activated Economic Analysis, the model is then sent to APEA to perform costing in the background, with 3 steps as follows. The first step is to map the ASPEN Plus unit operation models into equipment models in APEA. In this step, APEA loads data from ASPEN Plus and generates a default mapping for each unit operation model to models of equipment whose cost can be estimated. The second step is to size the equipment to determine the appropriate sizes of the equipment based on data from the unit operation models and streams in ASPEN Plus. The third step is to evaluating the model to determine costs for each piece of equipment. There are some tips for using the Activated Economic Analysis. After activating costing, you can evaluate the model immediately if desired by accepting the default values for mapping and sizings. If you check Auto Evaluate, then ASPEN Plus automatically starts the costing analysis after every successful flowsheet run. You can also perform partial costing of the portion of the flowsheet. You can also perform partial costing of portions of the flowsheet as well. If there are warnings from economic analysis, such as some unit operations whose costs could not be calculated, a yellow warning icon will appear on this panel. Click it to open the Equipment tab of the Equipment Economics form. Information about the warnings appears in the Evaluation Errors column. After performing the economic analysis, you can check the calculation results. The model's form is available at all times. This form displays a summary of the ASPEN Plus unit operation model data, with models of the same type in the columns on the same tab for easier comparison. The equipment economic form is available after the model has been evaluated. This displays a summary of the costs for the whole plant and for each equipment model. You can click the capital cost on the dashboard panel to see a summary of the costs. You can also click the utility cost on the panel to see the details of the utility costs. Click the other tabs on the Equipment Economics forms to see information about specific types of equipment. The Investment Analysis report is also available after the model has been evaluated. This opens an Excel spreadsheet produced by ASPEN Process Economic Analyzer, providing the investment analysis for the project. For additional information related to cost estimation, see the Help for Standalone ASPEN Process Economic Analyzer.